Hi, I'm Ricky. Today we're on the 38th episode of the Endless Runner series, and today we'll see part 2 of optimization. In the previous episode, we make an object pooling system to recycle all our entities. In the second part, we'll instead go script by script and see where we can improve our code on a more broader case. Remember, you can always download the entire project for free from Github. You can also follow me on Twitter to get updates on whatever I'm doing, and make sure to subscribe to not miss the next episode. Alright, so let's start. Damn it. Alright, so normally when I do optimization in my game, I just go script by script and see whatever I can improve. But of course we're not gonna do that now because that will take hours. Instead, I selected all the scripts that need to be optimized and we're just gonna modify those. Now that doesn't mean that that's all there is to it, but there are definitely some things I will still improve after the end of this episode, but these are the main ones. Alright, so let's start with animation prefabs. In this script, we spawn an animation and we change the animation sprite through this function right here, and then we instantiate it. And we also use getComponentInChildren to change the sprite, which is not very efficient. So instead of instantiating and destroying these animations all the time during gameplay, instead let's make a very simple and quick object pooling system for these animations. So let's make a list of sprite renders. And make sure to also add the system collections generic library. Then let's make a function to instantiate a new animation in our magazine. And for the code, we can mostly just copy this. We don't care about position or rotation. And we don't care about changing the sprite, but we do care about getting the reference, because the prefab is an object that has a child, and the sprite renderer is found in the child. So this way we add to the list the actual child, not the parent. And then we also have to disable the parent by default. Alright, so normally in my game I have a maximum of 2 animations at the same time, but just to be sure, let's spawn 3. Great! And now in our spawn animation, we just have to change the sprite of an existing animation. We don't have to instantiate it. By the way, while we're here, let's also put a debug log error in the default case. This way, if we try to spawn an animation that doesn't exist in our inventory, then we know about it. Alright, and in here, we first have to check whether the list has an animation inside. And if so, we instantiate a new one, and then we just pick up the first. Alright, so this way we are accessing the magazine, getting the first element, getting the game object, then we get the parent game object. Then we want to turn that to true. Change the position. We can also delete that. And then we change the sprite, or the child in this case. So we can actually do this to select the sprite renderer. And finally, instead of destroying it, we remove it from the list. Alright, and now we just need a way to put back the animation into the magazine. To do so, let's make a curtain. Alright, and make sure to also add the system collections library. Now, as a parameter, we require the sprite renderer, which is the one that we're going to put back into the magazine, and we're going to do the operations after 2 seconds. 2 seconds is basically how long the animation lasts. Now, first thing, let's put the animation back into the magazine. And then we want to disable the parent's game object. We could use a bunch of passages to get the parent's game object, but you could actually just ask as a parameter the game object's parent, because we're already caching it in here. Finally, we just need to call the curtain. If you notice you're accessing the list multiple times, So instead, let's try and find a way to only call the list once. Instead of getting the reference as a game object, let's do that with the sprite renderer directly. And I'm gonna name that reference as SR to indicate the sprite renderer, and the other one with GO to indicate game object. So this way we can replace this bit of code here with this value that we made here. This way we don't have to interact with a list so many times. Alright, and everything else will just replace the name of the game object. You can see it in here when we put the animation back into magazine. We are creating a new yield return to wait 2 seconds. But the thing is that this wait for seconds, it's always going to be the same. We're always going to wait 2 seconds. So we don't need to make a new value for it. Instead, let's go out to the top of our script and let's make a new value for that wait for seconds. And let's give it a value of 2. Also, because we are never going to change its value, let's also mark it as read only. And now in here we replace new wait with our variable. This is a relatively minor thing for optimization, but it's still something that you should do for good practice. Anyway, we are done with animation prefabs, so let's go to boat collisions. In here, as you may remember from the previous episode, we have a very ugly function in here. Before we do this big thing though, if we go below, we have a curtain in here, on lost life without losing, where the exact principle from before happens. We use wait for seconds, with the same value, we don't ever change it, we could replace it with a variable. So let's do that. Now let's go back into our big function, and ideally we don't want to do any of this stuff in here. That's because in here we're handling the logic that has to do with entities, but this script, it's boat collision. It shouldn't mess with entities. So instead, let's do something very simple. Let's go into entity type, and let's make a function that we're going to call when the player hits an entity, and it's also going to return a boolean value telling us whether the player should lose a life. Now let's go back to boat collision, and let's call it. And as the name suggests, if the value is true from the function, then we want to lose a life. And everything else that is in here, we are going to do it in entity type. Now we can remove the entity type class because we're already inside it. And now, for example, for the entity type collided with also doesn't matter because we're already inside, so we can just use entity type. And now in here, it happens when we hit a booty. So if we hit a treasure, we want to return false. Put entity into magazine, we can also just use game object, remove this too, and that's it for booty. Now for everything else that can be an enemy, we're checking first if it is an animal. If so, we call the next and try to remove a net. So if you are successful in removing a net, it means that we have defeated the enemy, so we return false. Else, if we don't have any nets, or if you just hit a rock, then we return true. Much better. We also have a comment in here, which I put a long time ago. Can remove this, and that's pretty much it. Now we could further improve this by making this function virtual. And then having each entity type define how the onHit player lose life function should act. And then making the entity type class as abstract, but that will mean making new scripts and having to redefine a lot of the logic of the game, and yeah, it's not really worth it. But just know that if you really want to be technical, if you really want to follow the solid principle as is, then this entity type class should definitely be abstract, and you should have a different script for each entity. But that's way over engineering for our little game, so can remove that. And this process was more about code clearance, but also a lot of the values that we didn't need to use, so we also made it a bit more performant, but it was mostly about code organization, yeah. Next up though, that's gonna be a big difference. Let's go into Spawn Manager. Spawn Manager is one of the first scripts that we ever made, so it's natural that it looks a bit bad now. So really the big logic of the script is in these two functions, increase speed and spawn entity. Let's start with spawn entity. In this function, which you call endless amount of times during gameplay, and also very often, we're using 2 times the getComponent function on this same entity. You can very easily change this. Instead, let's go back to entity type and let's add a reference to the rigid body in here. And make sure to mark it as protected. By caching the rigid body on awake, we can use the rigid body inside the entity type instead of getting it through the spawn manager in here. But before we do that, let's go back to entity type and let's mark awake as a protected function with a virtual attribute. This way we can modify the awake method in the subclasses. And this is something we have to look out for, because if we don't override the awake function correctly, you could very well miss the cache of the rigid body. So let's go in the Orca script, and in here we are overriding the awake method, but you're not doing so correctly. You can see that we are getting a kind of a warning in here. Instead of private void awake, we want to say protected override void awake. Protected because it's the same availability of the main function, and override because we want to override it. So we can remove the rigid body reference that we have here, and instead of this, we call the base. Alright, now back to entity type. Let's make a new public function called update speed. In this function, we are basically going to do the thing that we're doing in Spawn Manager right here. So instead of accessing the rigid body, we just call that function. Of course, we don't use spawn entity because we're already inside it. We didn't use getComponent because we already have a value for rigid body. And for the velocity, we put new speed. Also, instead of putting 0 as the velocity for the rigid body, let's put the current rigid body velocity of the X. This way we don't interfere with other scripts that are trying to move the rigid body, like the Orca that moves from side to side of the screen. And while we are here, let's also add a null check to a rigid body, because for things like the octopus tentacle, they don't have a rigid body. Finally, in Spawn Manager, let's first cache the value of the entity type, and then use it both to start the entity and to update the speed. Great, this way we have deleted a getComponent call. Alright, second part is increase speed. And in here we are calling GameObject.findGameObjects with tag. This is not the type of function that you want to call a lot of times, it is very inefficient. So instead of using this function, we're just going to store into a list all the entities that are currently on. We're doing something very similar already in our object pooling system. So let's go into Entities magazine and let's make a list of GameObject. We are going to do basically the reverse process of our Entities magazine. So when we request an entity from the magazine, we add to the current entities in game the one that we just requested. And then we do the opposite when we put it back into the magazine. Now, because we want to access this list of entities from another script, that is from the Spawn Manager, we can just make this public. We don't want to change it though, just read from it, so let's add a get property. Finally, we don't really care about serializing this list, so we can also mark it as static. Now back in our Spawn Manager, instead of using this code and getting an array of our entities in game, we can just use the list that we just made. This way we are not making a new array on the go every time, and we're also not using the GameObject find object with tag, which is very expensive. We're still using getComponent on all these entities, which is very bad, and there is a way to fix that, but that will require a lot more work to do, which I'm not gonna go into this episode because it is already pretty long. Instead though, we can replace rigid body with entity type and use the new update velocity function that we made before. A bit better. Alright, so that's it for the Spawn Manager. Let's hop into finish line. In finish line we only have 2 calls, one for when we hit an entity and one for when we hit an NPC. And in both cases we're using getComponent. Now let's start with the NPC. This is fairly simple. We're trying to get a value of the NPC, we're trying to get a reference, but there's only one NPC at a time in our game. So instead we can go into the NPC manager and see which NPC is active right now and disable that. Now our current NPC though is not currently public, so let's go into NPC Manager and let's make a public property. And this way we have avoided a getComponent call. Now for the entity it's a lot harder, because there are multiple entities active at the same time. Now in BoatVenture case, all entities go one after the other in a very specific order. Technically, if we wanted to, we could make it so that instead of using getComponent or the thing that we hit, we could simply have a list of all the entities that are in game right now, which we already have, and then simply look at the latest one, so the one that has been spawned the earliest, and therefore is also the furthest in its travel. You can't do that because the entities list that we have right now is of game objects. It's not in entity type. So it doesn't make any sense because we still have to use the getComponent function. If we had a list of entity types instead of game objects, then that would be possible. And we could do that, but again we'll have to redefine a lot of the stuff that happens in here, which is pretty tedious. Alright, now for some simpler stuff, let's go into Add Manager. In here, nothing fancy, we're just gonna replace the curtain that we have in here. And make sure you made that wait for seconds real time. Now let's go into Pause Manager. In Pause Manager we have an update function that checks for the letter P in our keyboard so you can toggle the pause. But we don't really need this bit of code in our actual game. We don't have a keyboard with our build game, we're using a phone. So if we are on the phone, if we are on our build game, let's disable the update. So on Awake, we check whether the application is running on a mobile platform. So if you are not on mobile, so if you are on PC, then we disable the update. Having one less thing that runs on update is always good. Let's hop into player bonus. In here we have this get bonus function, which tells us which kind of bonus the player has collected. This also was one of the first scripts that we made, and there is one big error in here. We're using the while function, but we actually don't need to, because this if, else statement is always going to go into one of these three cases. We don't need a while loop. We're never going to make more than one loop. My bad. Now we can also remove the breaks. And let's focus a moment on the actual if statements. Let's start with the nets. We are asking whether the nets level is measured than 0 and whether we can add a net. But these two things should actually be only one. Let's go into the next script. In here we have this canAddNet property, which tells us whether the current amount of nets that the player has is less than its maximum value. The maximum value being the nets level. Now first thing, properties should have a capital letter. Second thing, we should integrate the other part of the if statement in this property. I'm talking about this part here. This way the canAddNet property actually tells us whether we can add a net or not, and we don't need to depend on any other thing. We can also remove this, and if we go back, we need to change the capital C, and much better. And it also looks better on the code. Now we can do the same thing on the lantern, only in this case we have to depend on another script, but it actually doesn't matter. Now we're going to do something very similar with the lantern. Because we're going to do something with the lantern, we're going to add some extra fuel, and we're going to spawn an animation called lantern. We should have a property on the lantern telling us whether we can add the lantern fuel. So let's hop into lantern and let's make it. And for the actual requirement, we can go back to player bonus and just steal this. Let's go back. We use the property and it looks a lot better. Alright, and while we are here, let's also go back to lantern, and you can see that we are getting the system collections library, so that means we're using a curtain, here it is, and we can apply the same process that we did before. Good. Now let's go into shop item. Alright, and in here the only thing we want to change is item type, because it is public when it shouldn't be public, and it is capitalized when it shouldn't be, because it's just a variable. Now ideally you would want to change this to uncapitalized like so, but be wary if you do this, because that means that you have to reset all the enum values in your shop where you have the item type. I'm gonna do it because I just want to make some clean code, but if you have a lot of items, don't change this. or else you're gonna have to spend a lot of minutes in your shop having to reset everything. And then also change the values in here. And that's it. And if you go back to Unity, here is the error telling us that a certain value doesn't exist. Let's replace it with a new one that we made. Perfect. Let's go into Unlock Enemies Manager. In here, on update, we are trying to call increase difficulty every time we go through a certain amount of yards. The thing is, on update, we are only doing this one thing. So if we don't need to do this one thing, we should stop the update. How do we know when to stop increasing in difficulty? Well, we already have a function that does that. When the final case of increased difficulty has been called, then that means that we can stop the update. Alright, and finally, let's go to wind. In here, this is a very minor thing, but we are changing the canvas through one of our functions, that is setFlagUI. In here, we're getting the scale of a wind image and changing the vector on the X to revert it. Instead of creating a new vector on the go every time, let's create two variables for the vector, one for the normal flag and one for the inverted flag. And because we don't ever need to change them, let's also mark them as read only. And that's it. Alright, and finally I'll give you a final test to show you all the features, but that was really just modifying code, so it doesn't really make sense. I already tested everything myself. If your game does not work though, then let me know, we can see what may have happened. Alright, so that's it for this video, I hope you learned something new. If you have any doubts or any suggestions about the next topic that you'd like to see, do tell me in the comments. And if you're having any trouble, remember you can always download the entire project from GitHub, and you can also join my Discord channel and ask me for help directly. I'm also developing a new game right now, it's called AA, there's a teaser trailer, and you can follow me on Twitter for all updates on it. All links in the description. Finally, make sure to like, subscribe and share the video and all that stuff, and I'll see you next time. See ya!